Today's lesson is antiderivatives, which is really doing derivatives backwards. It's what integration is all about. This first sentence, I'm not sure what they're talking about, so I am going to go in here and just cross it out. All right. An antiderivative is the original function. General solution due to its constant of integration. The C stands for the constant of integration. You're like, what are you talking about? If I integrate f prime of x dx, I'll get back to the original function plus c. Okay? You're integrating the derivative. You're going back to the function, and you add c. And we'll talk about that in a minute of why. This symbol means integration. An indefinite integral has no limits, like what I wrote here. A definite integral is like what we did when we did 0 to 2 on those graphs. You have bounds. It tells you where to integrate from. Okay, so I'm going to, first place, all of these should have a derivative in it. Okay. And in order to get 0, you would have integrated a constant. All right. That has to be the derivative. So this is any constant. When you take the derivative of a constant, you get 0. If you have a constant, it's kx plus c. The c is just the constant. Okay? This is k times f of x plus c. This is f of x plus g of x plus c. There's only one c. This is the important one, the power rule. Okay? When you do the power rule, you're taking the derivative, you add 1 to the exponent, and then divide by the new exponent. And the guy that wrote these likes to call this, add, divide, conquer. But, never mind. Anyway, in other words, it's asking you to find the general solution to this integration. I need the antiderivative. I want to know what's f of x so that the derivative is equal to 3x squared. Well, I'm going to use my power rule. You add 1 to the exponent. 2 plus 1 is 3. And divide by the new exponent. And then you add a plus c. So you end up with f of x is equal to x cubed plus c. That's what the integration is equal to. Or the integration of that. Or the integration of 3x squared is x cubed plus c. Because when I take the derivative of x cubed, you get 3x squared. Why do you need the plus c? Well, what's the derivative of x cubed plus 7? What's the derivative of x cubed plus 10? What's the derivative of x cubed minus 42? Every single one of them, the derivative is that. So you need the c for the general solution. When they're added together, that's what this one is. You can do them each separately. Do the power rule for every single one of them. So I've got x to the 4th over 4 minus 4x squared over 2 plus 2x plus c. And then I usually clean it up and say my integration is equal to 1/4 x to the 4th minus 2x squared plus 2x plus c. But you need the c. Well, mark it wrong every single time. I'll give you 10 problems and you forget C 10 times, you miss 10 points. Okay? So don't forget the C. All right, this one you want to rewrite first. So I'm going to integrate 8x cubed plus 1/2 x to the negative 2. Now you can do the power rule. 8x, add 1 to 3, you get 4. 1/2 is a constant out front. X to the, if you add 1 to negative 2, you get negative 1. Clean it up, you get 2x to the 4th minus 1 over 2x plus c. This one I'd rewrite 1/4 x cubed plus x to the negative 2. So you have 1/4 x to the 4th over 4 plus x to the negative 1 over negative 1 plus c. So you get 1 over 16 x to the 4th minus 1 over x plus c. Good stuff. Okay, this one, there is no quotient rule. Okay, no quotient rule. So you just have to clean it up. So you have x squared over x to the 1/2 plus 2x over x to the 1/2 minus 3 over x to the 1/2. Then that's the integration of x to the 3/2 plus 2x to the 1/2 minus 3x to the negative 1/2. And don't forget your dx, the variable of integration. Power rule, x, you add 1, x to the 5/2 divided by 5/2. X to the 3/2 divided by 3/2. 3x to the 1/2 divided by 1/2. And thou shalt never leave me fractions in a fraction. Okay? So you have 2/5 x to the 5/2 plus 4/3 x to the 3/2 minus 6x to the 1/2 plus c. Okay? Leave that one for you to do on your own. This one, we don't have no chain rule. So you FOIL. So you have 2t plus 3 times 2t plus 3. And I'm going to integrate 4t squared plus 12t plus 9 dt. Power rule, 4t cubed over 3 plus 12t squared over 2 plus 9t plus c. So 4/3 t cubed plus 6t squared plus 9t plus c. General solutions. All right, the answer to this one's D. Work it yourself. Okay, now there's one more thing in notes, so don't go away. I have to do trig. Okay, up at the top, these are just asking you to find the derivatives, which is a good practice. We haven't done that in a while. The derivative of sine is cosine. The derivative of tangent is secant squared. The derivative of the secant is secant times tangent. Derivative of the cosine, negative sine. Derivative of the cotangent is negative cosecant squared. And derivative of the cosecant is negative cosecant cotangent. Don't forget your x's or u's. Okay, remember, if you take the derivative, it starts with a c, it's negative. These you're going to do in reverse. I'm going to integrate cosine, you get back to sine. You integrate secant squared, you get back to tan. This gets you to secant. Be careful here, the derivative of the inverse, antiderivative of sine is negative cosine. All right, ask yourself, the derivative of cosine is negative sine, so this has to be negative, so you get the right answer. This is negative cotangent, and this is negative cosecant. All right, know your trig. Same thing. The 4 comes out front. The antiderivative of sine is negative cosine, and you still add the c. Okay, sometimes you're going to have to use your trig identities to simplify them beforehand. Okay, cotangent in sine, I can't do that. It's not one of my pretty ones, but the cotangent is cosine over sine times sine. These guys cross out, and now I'm just taking the derivative of the cosine of x, and you get the sine of x plus c. All those trig identities we learned, you said, when am I ever going to use them? Guess what? Today's the day. Okay? Tan squared plus 1, that's the secant squared. Pythagorean identities. Oh, I'm sorry, I changed to x's. I hate those y's in there. The derivative of the secant squared is tangent plus c. You got to know your trig identities. If you don't, go find a pre-cal book and learn them. Okay. This I'm going to change to the sine of x over the cosine of x times 1 over the cosine of x. Sine over cosine is tan. 1 over cosine is secant. Now I'm going to integrate, and that's the secant of x plus c. Know your trig identities. All right. I don't think I did number 4. Had to think about it. This one, what do? You have 3 over the cosine squared of x plus 2 cosine x. And I got to multiply top and bottom by the cosine of x. So I get 3 plus 2 cosine squared x over cosine squared x. Is that helping me? No. All right. We'll come back to that. I don't want to do that right now tonight. You'll have to come to the Zoom and listen. All right. We're looking for a particular solution. They gave us an initial condition. Okay. So first I'm going to integrate 1 over x squared dx, which is the integration of x to the negative 2 dx. When you find the antiderivative, you get x to the negative 1 over negative 1 plus c, which is equal to negative 1 over x plus c. That's f of x. Okay? Well, it tells me right here, if I plug in 1, I get 0. So this is 0 equals negative 1 over 1. So now c is equal to 1. So my particular solution to this problem is negative 1 over x plus 1. Okay, the steps there is we simplified, find the antiderivative, plug in the values they gave you, and solve for c. And then you have your particular solution. Okay, so this one, I'm going to integrate negative 6z squared minus 3 dz. So that's negative 6, I'm changing to an x, over 3 minus 3x plus c, which is negative 2x cubed minus 3x plus c. That's f of x. They told me when I plug in 0, I get negative 6. So now my particular solution is negative 2x cubed minus 3x minus 6, and that's the answer. You need to know how to do particular solutions on your homework. Okay? These are kind of interesting. They give you the second derivative. They tell you something about the first derivative and the function. And they want you to get all the way back to the original function. So if I integrate f double prime of x, I'm going to get f prime of x plus c. So the integration of 2x plus 3, oh, I forgot my dx, is 2x squared over 2 plus 3x plus c. That equals f prime of x. And it tells me when I plug in 2, I get 8. So 8 is equal to, these guys cross out, 2 squared is 4 plus 6 plus c. So c is equal to negative 2. So now I'm going to integrate x squared plus 3x minus 2. And I get x cubed over 3 plus 3x squared over 2 minus 2x plus c. That's f of x. And they told me if I plug 2 into that, I get 0. So this is 0. 2, what's that, 8 thirds plus 2 plus 12 halves, which is 6, minus 4 plus c. So 8 thirds plus that's at 2, which is 6 thirds. is 14 thirds. So c is equal to negative 14 thirds. So my particular answer in that case is 1/3 x cubed plus 3/2 x squared minus 2x minus 14 over 3. Good problem. Let's do this one too. If I integrate f double prime of x, I get dx. I get f prime of x plus c. So the integration of 2 dx is equal to 2x plus c. That equals f prime of x. It's telling me when 1 is equal to 2 times 4 plus c. So c equals negative 7. Now I integrate 2x minus 7 dx. And that's going to give me f of x. So you get x squared minus 7x plus c equals f of x. They tell me I plug in negative 1, I get negative 2. So what's that, 8? So that c is equal to negative 10. So f of x is equal to x squared minus 7x minus 10. Okay, that's this one. This one belongs over here. This one, this looks sort of like a slope field, sort of. It's taking this function and adding all sorts of different c's to it. It moves it on your graph, right? So if I integrate 2x minus 1 dx, I get x squared minus x plus c. That equals f of x. They told me 1 is on there, so 1 is equal to 1 minus 1 plus c. So c is equal to 1. So my function is x squared minus x plus 1. Same thing here. They want me to integrate the cosine of x dx. The derivative of the cosine is sine x plus c. And you plug that in, and you get 4 is equal to the sine of 0 plus c. The sine of 0 is 0, so c is equal to 4. So this is the sine of x plus 4. Good problems. Okay, now what? You got to integrate that. Derivative of the integration of sine is negative cosine. Because remember, when you take the derivative, it changes its sign. Plus 7x cubed over 3 plus c. Looks like b. Alrighty, that's all there is to antiderivatives and particular solutions.